Ladies and gentlemen, my name is Joshua Olusegun. It's my pleasure to welcome us to our basic econometric class. And let me start by appreciating those of us that have been joining us. So far, we have handled part 1, part 2, and today we are moving to part 3. And in this part 3, we shall be considering functional forms of regression models. And we shall be using R Markdown. So by way of introduction, let us recall that one of our primary concerns with linear regression model is the linearity assumption. That is, the models are linear in parameters. They may or may not be linear in variables, which is the first assumption considered in our last class. So we would like to consider several models that are linear in parameters, but are not necessarily so in the variables. One major advantage of it is that it may be a good step to re-specify our model in case the linearity assumption is violated. So we shall be considering various models which are frequently used in empirical analysis as alternative to situation whereby the variables are in linear form. So we have the log-log or double-log models, where the dependent as well as the independent variables are all in log forms. We have the log linear models, in which the dependent is in log form, but the independent variables are in linear form. Then we have the linear log models, where the dependent variable is in linear form, but at least one or more of the independent variables are in log form. We have the reciprocal models, where the independent variables are in inverse form. Then we have the standardized variable regression models. So we shall be illustrating using Longley data sets to illustrate the various models. So let's start by loading the Longley data sets. The advantage of using Longley data set is that the moment we install R, we can find the data in the data set package. So let's go straight to the code. We are already familiar with the value of cable extra, so that it helps us to produce a very neat table. Now, the code to load the data set is data, then just put Longley. Then to look at the force-6 observation, just not forget head refers to force-6 observation. Then cable is added in order to generate publication ready table. So let's run this chunk. Yeah. So this is, so we have about 6 variables. We have GNP deflator, it's a measure of inflation. No, sorry, 7 variables. We have the GNP. We have the number of unemployed, number employed in armed forces, the population, the year, and number of people employed. So Longley is a macroeconomic data set which provide a well-known example for a highly collinear regression. It has 7 economic variables from 1947 to 1962. So we have the GNP deflator, which is GNP implicit price deflator, using 1954 as the base year. We have the GNP, which is the gross national product, unemployed as number of unemployed, armed forces, a number of people in the armed forces, population, referring to non-institutionalized population from the age of 14 years and above. We have the year standing for the time, then employed as number of people employed. Now, if you read more about Longley, we can access this journal article, Appraisal of Least Square Programs from Point of View by Longley, 1967. So the starting point is to fit our linear regression. Then we fit the log linear, we fit linear log, we fit the log, we fit the reciprocal, as well as the standardized regression. And we try as much as possible to pay attention to interpretation of the result. It's very, very vital. So for the linear model, we want to predict employment using all the other covariates. So in that wise, employed is our dependent variable. And as we learned during the last class, the moment you want to include all the other variables as independent, you can just use this approximation which stands for as a function of, then you just put dots, comma, then you define your data. Then we use model summary to produce a publication ready table. So let's run it, run the chunk here. So let's look at the results. So the intercept is minus 3482. The GNP deflator, the coefficient is 0.015, but insignificant. GNP minus 0.036, insignificant. Unemployed minus 0.02, significant. Armed forces minus 0.01, significant. Population minus 0.051, insignificant. Then we have the year 1.829, significant. Then we have our R squared to be 0.995, adjusted R squared 0.992. We have our AIC, PIC, log likelihood, our F, then the root mean square error. So let's attempt to provide a kind of interpretation. When you run a linear model, in linear model, the dependent variable is linear. All the other variables also, they are in linear form. So you interpret it in terms of unit change in dependent variable explained by unit change in the independent. We are coming to that. But before that, let's look at the interpretation of the adjusted R square 0.99. So this indicates that approximately 99.2, since we are dealing with more than one variable, adjusted R square should be what we need to interpret. 99.2% of the variability in employment over the period studied, 1947 to 1962, is accounted for by the independent variables. That is GNP deflator, GNP, number of unemployed persons, number of armed forces personnel, population, and the year. And that takes us to interpretation of the intercepts. Usually intercepts, any value of intercept refers to a situation whereby all the coefficients of the independent variables are assumed to be zero. So the intercept of the model is minus 3482.259. And statistically significant at 1% level. We're talking of economic world. It doesn't have any meaningful real world interpretation because of the negative sign. And like I said, it represents the predicted value of employment when all independent variables are equal to zero. And that's a situation that cannot occur in reality. For instance, variables like year cannot be zero, population cannot be zero. So the intercepts serve as just a statistical function to correct the position of the regression line. So there is no way you can interpret that economically, doesn't make any sense. So, and that takes us to interpretation of the coefficients. Among the predictors, three variables have statistically significant effect on employment. And you have to pay attention to those ones. The first one is the number of unemployed persons, which has negative and significant coefficients, that is minus 0.02. So in terms of interpretation, I want you to please pay attention because we'll be interpreting in terms of 1 unit to 1 unit. So all things being equal, ceteris paribus, an increase of 1 unit in the number of unemployed is associated with a decrease of about, we're talking of decrease because the magnitude is negative, of about 0.02 units in employment. Look at it, units. 1 unit, the number of unemployed, decrease in the number of employment by 0.02. Let's pay attention to that. Similarly, the number of armed forces personnel has negative and highly significant coefficient as minus 0.01, suggesting that increase in armed forces personnel are associated with lower employment levels. That is, a unit increase in number of armed forces personnel will cause a decline in employment by 0.01. That's very, very clear. But in contrast to the number of unemployed as well as armed forces, the variable yield has a positive and significant coefficient, that's 1.829, indicating that employment tends to increase by approximately 1.829 units each year. So let's understand that. And since the employment is measured in numbers, so that's number of people employed, increased by 1.829 each year. So let's understand the interpretation. So this is talking of upward trend over time. So all the other variables, GNP deflator, GNP population, they do not have statistically significant effect on employment in the model, as their p-values exceed conventional significant threshold of 5%. So overall, the model fit the data exceptionally well. That's going by the value of the R square, and highlights important temporal and structural factors associated with changes in employment over the analysis period. So, and that takes us to log linear model. It's a type of regression model where the dependent variable is transformed using the natural log, but the independent variables remain in the original linear form. What are the purpose of log linear model? The main purpose of a log linear model are to, number one, model percentage change in the dependent variables for a unit change in the dependent variable. Please, let's take notes. Log defines percentage change in the dependent variable. The independent variables are in linear form, so it's percentage change for unit change. That is, for every unit change in any of the independent variable, then we want to know what's going to be the percentage change in the dependent variable. Another reason for log linear model is to stabilize variance, that is, reduce heteroscedasticity if the dependent variable has a skewed distribution. Another advantage is that it helps meet the assumptions of normality in regression when the dependent variable is highly skewed. So the general form of the model, you can see that just the dependent variable is a natural log form. All the independent variables are introduced in linear form. So the coefficients are what is called semi-elasticities. That is percentage change in the dependent variable for a unit change in the independent variables. What are the advantages? Number one, interpretability. So it's very simple to interpret. The coefficients show percentage change in dependent variable for a unit change in independent. Number two, reduces skewness. It's very useful when you are dealing with skewed dependent variables such as income, sales, or prices. It feeds data where growth is multiplicative, so it helps us to handle exponential growth. So we are talking of population growth, economic growth, price growth, yield growth, all manner of growth. These are the kind of model that usually fits such relationships. Yes, it improves model fits, often increases the coefficient of determination, and makes linear regression assumptions better. The log linear model is particularly useful whenever a researcher wants to interpret the impact of predictors in terms of percentage change in the outcome. So, and this is what we are doing in growth-related dependent variable situations. So now illustrate, um, let's illustrate the model with our longly data. So this is the code in the chunk. So we can see that we now bring in the dependent variable employed in log form. You can say lm log of the dependent variable as a function of all the other ones that are included in linear form. That's why we still put dots. Then we define our data. So let's run this chunk and look at the results. So our intercept is minus 52.071. The GDP deflator is extremely low, 0.00. We have 0.000 here because the result is limited to 3 decimal places. So we have the GNP, the unemployed, we have the armed forces, the population, and the year. And if you look at it carefully, you can see that the number of variables that are significant in the linear model are still the ones that are significant when the log linear model is fitted. So let's look at the interpretation. The log linear regression model provides valuable insight to the factors associated with changes in employment over the period analyzed, like the linear 2. So the model demonstrates an excellent fit. The adjusted R square is 0.992. So can still interpret it in terms of 99%, 99.2% of the variability in the log. Now, see the interpretation now. In the log, not in employment. In the log of employment is explained by the independent variables. So the intercept is still negative and significant at 1% level. So in a log linear model, the intercept reflects the baseline log when other variables are 0. As in most economic models, and as we discover with the linear model, the value that is the negative value has limited reward interpretation because variables like year, population, economic aggregate cannot realistically be 0. So the essence of the intercept is just to adjust the level of the regression line to fit the observed data. So going to the explanatory variables, the number of unemployed shows a small but significant negative coefficient, minus 0.000. And that suggests that an increase in unemployment, don't forget that is units, is associated with a slight proportional decrease, that is percentage in employment. Now, in another word, you can say if the number of unemployed increased by 1 person, as 1 unit. Then the number of unemployed will decrease by 0.000, but very sure we could use maybe more than 3 decimal places, or have maybe 0.00001 something, the number of people employed. Similarly, the number of armed forces personnel has negative and very small negative too. So, and that implies that if the number of armed forces personnel also increase by 1 person, it's going to be linked to marginal percentage decline in number of people employed. That is clear. So coming to the variable year, it has positive and significant coefficient, that's 0.029. So the independent variable, we have to interpret it in terms of the units. In this case, since the unit is year to year, that is each additional year is associated on the average with approximately 2.9% increase. We're not talking of percent increase in number of people employed. So since in a log linear model, the coefficient on continuous predictors can be interpreted as approximate percentage change in dependent variables per 1 unit increase in the predictor. Let us not forget that. As a linear model, all the other variables are insignificant as their p-value will exceed the conventional significance threshold. So overall, the model highlights the importance of temporal trends in employment growth, as well as the model's but significant negative association between employment and the number of unemployed and armed forces personnel. The model's very high explanatory power indicate that these factors together closely track the observed changes in employment, percentage change in employment over the study period. Yeah. So let's move to the next one, which is the linear log model. Don't forget the other one is log linear. So when we talk of linear log, so it's a type of regression model. The dependent variable in this case is expressed as a linear function of the natural log of some of the independent variables. So in terms of interpretation, so it's going to be percentage change in the independent variable, let's say vector of x associated with unit change or absolute change in the dependence. Let's take note of that. So let's run it. So what we're trying to do initially, because all the variables, the independent variables, they're actually in linear form, so we have to generate the log transformation of the independent variables. So that is why we need tidyverse package for manipulating the data sets. So this is, we say take, we have LDF, that's log of GNP deflator, LGNP, log of the GNP, and so on and so forth. So the moment we have that one, then we will have to select the variables of interest. So that's why I call it link log data. I select employed, because this employed is the number of people employed. It can't be in log form. It is the independent variables in this situation that will be in log forms. That is what we have here, so that we can run the linear log model. Our dependent variable employed is in linear form. Don't forget, we have already specified all the independent variables in log form. That is why we just say point, comma here, and we define our data. So let us run the chunk and look at the results. Let's run the chunk. So this is the results. So the intercept is still negative. The log of the GNP deflator is significant. Unemployed, significant. So we can see here significant, and so on and so forth. So let's look at it. So the linked log regression model estimates the relationship between the dependent variable and a set of predictors expressed in log form. So the model demonstrates, so let's look at the R squared. The R squared is 1. Yeah. So the R squared, the adjusted R squared is 1, indicating that it accounts for virtually all the observed duration independent across the sample. So the AIC and the F statistics, they are large, which further support the robustness of the independent variables used in modeling the unit change in the number of people employed. So among the predictors, many of the variables show statistically significant effects. The log of employment exhibit a strong and highly significant positive association with the dependent variable. Yeah, let's go back to the model. I think that maybe that is where we made a mistake. Yeah, let's go back. Let's go back to the variables that we generated. So we generated LDF as GNP deflator, LGNP as log of GNP, LU as log of unemployed, LAF as log of armed forces, LPOP as log of population, LYR as log of year, LEMP as log of employed. Log of employed cannot come in. Employed is the dependent variable in our situation. So we have to remove this. I think there is one that we have not included, which is GNP. So LGNPs, I think. And maybe that is why we have 100% coefficient of determination. So before we begin to ask that question, I think let us correct that. So let's run the chunk again. So let's run the chunk. Yeah, beautiful. So let's look at the results again. So the intercept is still negative. Now it's fine. You can now see that the log of the GNP deflator is insignificant. Unemployment, like before, has negative coefficient significant. Armed forces, like before, negative and significant. Then the years also should be. So, okay, in this case, the year is insignificant. So let's look at the adjusted. Now, you can see that the adjusted R squared in our situation is 98%, not 100%. So I think um, that's where we are the mistake. So let's quickly correct ourselves here. So the R squared here is 0.98 or 98%. This 98%. Okay, so uh, indicating that, let's correct this. So indicating that 98%, about 98% variation in the dependent variables. I explained by the independent variables. Yeah, so sorry for the mix-up. Yeah, I think the AIC, the F statistics, the values will have changed. The AIC is 26.8, not 50. Then the F is 175. So let us just change those two. So this is 26, it's still large, 26.5. And this is 175, so point something. So, and they still show, this supports robustness and the explanatory power of the model. So, in our situation, so we are no longer considering, yeah. So this is not there. So we have to delete all this. Sorry, I think we have to correct this later. Let us just go back and interpret our coefficient directly. Just let's focus on the three that are all right. I think two. So we have, the intercept is negative. So like before, it doesn't have any economic meaning. The log of unemployment is minus 3.291. So this is saying that a percent change, that is 1%, 1% change or 1% variation in number of people that are unemployed will lead to decline in employment by 3.291. No, we are looking at the number. It's not percentage now when it comes to, this is log, link log. Let me take armed forces as another example. It's minus 2.364. So which means a 1% increase in number of armed forces personnel will lead to 2.364 decline. Understand that? Decline in the number of people employed. So let's get it right. Okay, yeah, all the others are insignificant. So, and don't bother yourself interpreting insignificant variables. So let's move forward. And that takes us to log-log model. Log-log model. So in log-log, otherwise called double log model, in this case, both the dependent variables and some of the independent variables are transformed using the natural log. So this is the general format. They are all transformed. So in log-log, the coefficient directly represents the elasticities. So in that wise, we are saying percentage change in dependent variables resulting in percentage change, percent. Understand that? Holding other variables constants. What are the uses of log-log model? Number one, the elasticity is meaningful. So in economics and social sciences, researchers often care about proportional or relative changes rather than absolute changes. The model captures nonlinear relationships, but it's very, very okay because we can express it in linear form because the coefficients can be transformed so that it will be linear in parameters. Then the variance is stable. So logging can reduce heteroscedasticity because it compresses large values. The model makes interpretation scale-free. Coefficients are dimensionless percentages, so making it easier to compare effect across variables measured on different scales. So the functional form and underlying relationship. So a log-log corresponds to an underlying multiplicative relationship and is widely used in economics, in environmental studies, in finance, and marketing. So now that we have transformed all the variables in log form, we will select all the log, you can see. We select the log of employed, the log of GMP deflator, and so on and so forth. And we run the model. So in this situation, the log of the number of people employed is used as the dependent variable. And since all the others are also in log form, we just say dot here, and we define our data sets. So let's run the chunk. Good. So the intercept is still negative. And if you look at it, the log of unemployed, negative. Log of armed forces, negative. Population, the log is negative. And yield is positive. So let's look at the interpretation. So the log-log examines the relationship between the log of the dependent and the log of the dependent variables. So which makes it very simple for us to estimate and interpret the elasticities. If you look at the explanatory power, that is the adjusted R square. The adjusted R square 0.989, 0.99. This indicates that approximately 98.9 of the variability independent variable, that is the log of number of people that are employed, is explained by the independent variables. Yeah, so the F statistics is large, indicating that the model is statistically robust. The intercept is still negative, and we have considered the fact that negative intercept has no economic value. So the advantage is just to adjust the level of the regression line. Let's look at the predictors. So several of them show statistically significant effects. So the log of the number of unemployed person has negative and significant coefficient, that's minus 0.08. And let's pay attention to the interpretation. That is a 1% increase in unemployment is associated with an approximately 0.08 decrease in the dependent variable. In a similar fashion, the log of armed forces personnel also has negative coefficient as minus 0.034. That is 1% increase in the size of the armed forces personnel is associated with 0.034% decrease. All that is percent. Don't forget that, it's very, very vital. So the log of population has a relatively large negative coefficient, that's minus 1.297. That is 1% increase in population leads to estimated 1.29% decrease in the number of people that are employed, holding other variables constants. So this negative might reflect the demographic structure or structural pressures that counteract growth in number of people that are employed. The log of the year is positive and statistically significant, 74.53. So which means a 1% increase in the year variable is associated with a roughly 74.5% increase in the number of people that are employed, which is our dependent variables. And it captures the strong underlying growth rate over the sample period. All the other variables, the GNP deflator in log form, GNP in log form, they are insignificant. Yeah, so overall, the double log model results highlights the significant negative effect of unemployment, armed forces personnel, and population on the log of the number of people employed. So the elasticities estimated from this model provide an intuitive way to understand how proportional change in niche of the independent variable relates to percentage change in the number of people employed, which is especially useful for economic and policy analysis. So that takes us to reciprocal model. A reciprocal regression model is a special type of nonlinear regression model where one or more independent variables are entered into the model in reciprocal form. That is 1 over x. So the relationship is nonlinear, but we can transform it so that it becomes linear in parameters. So we expect diminishing marginal effects that becomes almost negligible at large values of x. The economic theory, generally or natural science, suggests an inverse relationship. The curve is steep, decreasing or increasing when s is small, but becomes flatter as the independent variables become large. So let's fix a typical example is useful. We can see in various fields, agriculture, medicine, environmental, economics, and so on. So, and it's widely used by economics when modeling cost curve production functions. Environmental science in modeling pollutant concentration with distance. In medicine, dose response curve. In agriculture, when we are estimating yield function, and so on. So in this case, we need to transform the independent variables as reciprocal. So like GMP deflator, I call it INVDF now as 1 divided by that variable. So that is exactly what we've done. So INVU, that is 1 over unemployed, INVAF, 1 over armed forces, and so on and so forth. So then the unemployed also is 1 over employed. So in the modeling, we model the inverse of the number of people employed as inverse of against all the independent variables that are also expressed in inverse form. So, and this is what we have. That's what reciprocal model is all about. So let's run the chunk. Good. Yeah, the intercept is still negative. Then unemployed, negative and significant. Year, positive and significant. Emphasis is now insignificant. So, and let's look at the adjusted R squared now is 0.968. So the inverse regression model estimates the relationship between the dependent variables and the reciprocal of several independent variables. So each predictor enters as 1 over x, capturing how changes in small values of the predictor strongly affect the dependent variables, while large values have progressively smaller marginal effects. So the adjusted R squared is this should be 96.8% of the variability in dependent variables accounted for by the included predictors. Then the AIC is low, the F statistics is large, showing robustness of the model to all those variables that are included in the model. So the intercept is negative, and we say that it has no economic value. And the main advantage is that it adjusts the baseline of the regression line. So there is no real economic meaning. Then the reciprocal of the number of unemployed shows a negative and statistically significant effect. This suggests that the number of unemployed people is small, that is 1 over unemployed. That is when the number is small, the dependent variables decreases. So conversely, as unemployment increases, the negative effect diminishes. In terms of the year, it has a very large effect, which is 773. This means for smaller values of the year, there is a strong positive association with the number of people employed. So overall, the inverse regression model indicates that lower values of unemployment and earlier years are particularly influential in increasing the number of people that are employed. So it's strictly nonlinear relationship where the marginal effect of each predictor is strongest, particularly when the predictor itself is small. And that takes us to the last type of model, standardized model. A standardized model is an approach in regression analysis where all variables, the dependent, the independent, are transformed into standardized form before estimating the model. So another word for standardization is rescaling. So we try to rescale the variables to have a mean of 0 and standard deviation of 1. So the transformation is what is called standardized coefficients or beta coefficients. What are the advantages? Number one, it makes the coefficients comparable since standardized variables are unit-free. Number two, it allows researchers to see which predictor have stronger or weaker effects on the dependent variables, particularly when the variables are measured in different scales. It improves numerical stability. So in terms of application, they are very useful when the goal is to compare the relative strength of several independent variables. That is, we want to compare income in dollars, age in year, and so on, because rescaling will make all of them to be unit-free. Then, when we want to communicate results to non-technical audience, we find unit-free measures easier to interpret. Yeah, and it's especially useful when we want to build composite scores. In fact, we'll be talking more of this anytime we have opportunity to look at principal component analysis, PCA. And it's widely used in psychology, sociology, social science, in marketing, educational research, and so on. So to estimate it, we need the package lm.beta. So, and to estimate it, there are two steps. The first one, you estimate the linear model. Then you now find the lm.beta of the linear model that you have estimated. Since we have estimated the linear model, so the next thing is to just obtain the lm.beta of the model and obtain the summary. So let's run the chunk. So now that we have run the chunk, so we can now see our results. For our results, in fact, none of the variables is statistically significant, but they are just as good as high. All right, so since none is statistically significant, I don't have to discuss insignificant variables. So far, so good. We have looked at various ways to transform our variables, particularly when the linearity assumption is violated. So we can use the log linear, linear log, log, reciprocal, or standardized regression model. And we tried as much as possible to look at the advantages, disadvantages, where they are applicable, the interpretation, and so on. So that is exactly what we have come to do today. And if you need the variables, the models, then this is what we will have. So we'll try as much as possible to send this note to our email or I think we have a platform. I think we have a platform on WhatsApp. I think she will try as much as possible to update. So I thank you. I thank you again for coming. So that is the lecture for today. Now we will entertain questions or wherever we need clarification. And we shall continue to interact with you as long as you let us know the problem that you have. Even you can contact us on WhatsApp or various other mediums. So thank you very much.